Recently picked up these cheap video goggle things off eBay with a possible view to modifying them for something I'm working on at the moment. I sort of almost deliberately went for the cheapest ones I could find. So these are just composite input. There's no, you can get some of these that have got like SD cards that will do self-contained playback, but this is just strictly composite input. Despite which they seem to be claiming works with iPhone and made for iPad. Don't really understand what they mean by that. This box has sort of got quite a lot of other rubbish on it, like for example it's talking about MP3 and WMA bit rates, but it doesn't even support it, so this is clearly a generic box, but I think that's possibly a sign of things to come. So basically we get, actually the comes in this case is actually possibly the nicest part about the whole thing. Mains adapter, I think we know what we're going to expect on this. Designed by BY in California, yeah right. Listed power supply, but no UL, no CE, no markings to speak of. And you always know you're in trouble when they start misspelling stuff. Caution for use with information technology equipment. Bendy pins. I'm not even going to plug this thing in. So let's see what horrors lurk inside this thing. You can actually, well, that didn't take much, so you could plug this in and just pull this out and you'd have nice live mains, so that's not a very auspicious start. So pins, piddly little wires, no discernible isolation between the live and the output. I mean, that's just horrific. You know, all this stuff here is mains and this is connected to your USB socket, so pretty lethal. There's just no creepage distance at all on there. Sort of 2 transistor front end, half-wave rectifier, no filtering. Oh, that's interesting. There's actually an opto isolator on here, so that we've got, looks like we've actually got main side control stuff on this board as well. So yeah, fail. And they kindly threw this adapter into the box, of course, unfused, totally dangerous. So you plug that in and you potentially got your 30 amp ring main supply available on these bits of tin, because there's no fuse on there. So basically these are the glasses. Cheap plastic. I mean, the plastic is the cheapest sort of plastic. You know, it just feels really, really tacky and horrible. There's these little earbuds, and there's this AV in connector, which takes this rather clumsy big plug and quite a sort of stiff cable. And that cable goes down into this box. This is basically the battery. You've got an input here for your composite. They also give you a jack-to-jack lead, and it takes power for charging power from USB. But what? Why on earth have they used a barrel jack and not a micro USB on here? And then they've stuck it on the side, so it's all horrible, horrible, nasty. So obviously this thing is equally nasty. There's no adjustment, there's no eye distance adjustment, no focus adjustment. So, you know, as long as, you know, it's only really going to be usable if your eyes happen to be the right distance apart and you're not, you know, you don't use glasses or anything. Needless to say, it's pretty uncomfortable. Then you've got the weight of this thing sort of dragging down, so it's not impressive, to say the least, but we weren't really expecting it to be. Needless to say, the image quality is not exactly impressive, very low. You know, you can actually see the pixels, although it's actually quite hard to focus. I find I can't actually focus on this properly because there's no eye distance adjustment. Which is a bit hard to get the camcorder to pick it up. You end up sort of being cross-eyed, so as is, it's really not very effective. So let's see what's inside. Right, in here, so we've got the lithium battery as we'd expect, and it looks like all that we've got here really is the the battery charger and not much else, which I suppose one good thing it means that all the electronics are actually in this top piece, so you don't, if you're powering it from something different, you wouldn't actually, there's nothing here you actually need in order to actually get it to do something, which I suppose is one sort of benefit. But I think yes, there is a protection circuit on that battery. They claim this is something like 700 milliamp hours, but I don't really believe that. It looks big enough to be 700 milliamp hours. Let's take a look inside here if we can figure out how to get it apart. Can't quite figure out how this is how this is held together. Oh, now I see it. There's actually two screws in here, so you're supposed to sort of twist it that way and then get those screws out. But I didn't notice those. Oh well. Right, so it looks dangerous. Right, so not a huge amount on this PCB. We've got a Texas Instruments TVP 5150. That's a basically a PAL colour decoder chip that takes analog composite video in and outputs digital RGB. This Copin KCDA221. This is a chip specifically designed to drive displays like these, and I think Copin also manufacture these displays. This takes digital video in and actually outputs analog RGB. These actually take an analog input signal, which is quite unusual, but it probably simplifies the driver for low resolutions to actually drive the LCD at analog levels. And surprisingly, there's actually a PIC on here, PIC 12F683, which I'm guessing is mostly going to be just generating the I2C setup configuration for these chips. Not much else. There's a crystal or ceramic resonator, a couple of inductors, and not much else. Not sure whether there's an audio amp, whether one of maybe these are audio amplifiers, maybe a Class D, there's two inductors there, so maybe that's these two are Class D audio amps, but nothing else really in there. And so this TI chip, it's obviously designed as a sort of front end for composite video applications, supports all the various colour standards as you'd expect. Probably way over spec for what it's being used for in this device, considering the resolution. And there's a block diagram here, so we've got the composite in, programmable amplifier, all the colour processing, and then digital video out, plus various sort of sync signals out, and an I2C control to set it up. And here's some information I found on this Copin divider chip. So it's designed specifically for their own, these cyber display colour displays. So probably the most interesting thing is the fact that this actually produces analog out. So we've got this digital processing and rescaling. So obviously the other thing you need to do when you're driving the small display is actually resize it. But then the outputs are actually analog, and it's also got some backlight and power supply support for the display. So let's take a look at these displays. Well, these are really tiny. The actual display area is about 5mm or so. Let's fire this up and see what it looks like. Now this thing is really cute. I think this is a liquid crystal on silicon type device. And so this it's about 6 by 5 millimeters across. Zoom in on that. Yeah, so this chip's about 6 by 5 millimeters or so across. It's a bit hard for the camera to focus on it, but very neat little bit of tech. Just looking at how this thing's made up, we've got the chip itself on the end of the flex cable, then there's a single white LED backlight, and on the front of this bracket there's the front polarizer, so you can't actually see an image on there because there's no polarizer on it. If we stick that on there, it's quite hard to make out an image just because the camera. So it looks like they've taken some quite interesting tech, those little displays, and then just wrapped on. These lenses aren't particularly good either. These are plastic lenses and you get quite noticeable colour fringing on them, and just sort of wrapped it up in the cheapest bit of crappy plastic you can imagine. And these the manufacturers of these displays do make stuff for some quite high-end equipment by the looks of it, up to military type stuff. But this is obviously the bottom end of this market. I'm sure if you had some better optics, these things could actually produce some quite reasonable displays, but of course the optics are probably the most expensive part. I don't know whether they use these in that chip, but in the Google Glasses thing, but it's obviously going to be something fairly similar. But so quite an interesting piece of tech, and it might possibly get adapted into being something else soon. Stay tuned.